Introduction to NDE, Module 4, Glossary, Gary A. Pace, PE, CWI, Katy, Texas. Okay, so we're going to just talk about some terminology here that you might run across in non-destructive examination. One of them is, we'll start with corrective action. So this is an action taken or plans for actions to be taken for solving problems that occur during production. So you might have heard of a corrective action report. So we figure out, okay, we've got this weld, there's a flaw in it, a defect, we need to chop that weld out and replace it. Well, how are we going to do that? Well, we put together a plan for this, and then we put it in documentation, and then we follow the plan. So this is called corrective action, or a corrective action report would be the actual documentation of this. Critical flaw size. This is the minimum extent of a flaw, the depth, length, whatever, that is going to prevent achievement of a design goal for that part. How much undercut can we handle? How big of a slag pocket can we handle? How ugly can that weld be? What is our critical flaw size that we can live with for a particular part? Okay, so we got a defect. This is a term we're going to hear a lot. Defect. So a defect is any condition of a part that prevents achievement of a design goal. That's what we call a defect. So we can have flaws, we can have indications, but a defect is something that prevents us from achieving our design goal. Is this going to cause the part to fail? It's a defect. So it's a flaw that's a critical size or larger. We call it a defect. We can have a flaw, we can have an indication, but if it isn't of a specific nature and or of a critical size, then we don't call it a defect. It's just known as a discontinuity or a flaw or an indication. But a defect is something that it hits a certain size, then we've got to worry about it, and it's known as a defect. Let's talk about documentation. What kind of anything in engineering would be incomplete without documentation? We got to have documentation to back up what we're doing. If it doesn't have documentation, it didn't happen. So a documentation is a written or recorded proof, usually includes a picture or some kind of other data that we can attach to our documentation package, to our report, and it gives us an idea of what happened during the testing. During a controlled test, we followed a procedure. This is what we got. Here's a picture of it. Here's an x-ray of it. Here's what we had happen. So we need documentation if we're going to do non-destructive testing and do it correctly. We can't just have random he said, she said type of tribal knowledge for, yeah, Fred over there said it failed. No, we need a written report. We got to act like grown-ups. Should include the names, the date, the equipment used, any other vital information that we have should be included in there. The name of who did it, the person and their qualifications, who did the inspection, who did the testing, so that we can confirm that the part or the results of the test happened as we say they happened. So this is all needs to be done and included in the documentation package. So names, dates, equipments, once again, gets back to we need to act like a grown-up. Okay, let's talk about the term flaw. So any imperfection in a part can be considered a flaw. And by definition, all parts are going to have flaws. So when we get to flaw size, a lot of them are just too small to be of concern. We just don't care. They're not going to affect the structural integrity of the component or the part. So we just don't care about them. They're just a flaw. They're an imperfection. They're a discontinuity. But if they get to be a large enough concern, if they're beyond a certain size, they can cause the part to fail. And at this point, we end up calling them defects. So when a flaw gets big enough to cause failure, they're called defects. So that's the difference between a flaw and a defect. So permanent record, this would be something like an X-ray, or let's say now with cell phones, we take a picture of something that's, we do visual testing and there's a flaw, a defect that we need to remove. Then we can relook at it and confirm, yeah, that's a defect that we need to take out. We need to deal with that. So just a permanent record, pictures, anything that we can have, like I say, X-rays, radiographs, something that we can use to make disposition apart, and then or to confirm that, hey, this is good. So permanent record, and this is going to go into the documentation package that might be specified for particular inspections, depending on what we're doing and who we're doing it for. They might need a permanent record, and in the documentation package it says, yeah, you did this and there's no defects in there, or any defects there were, you guys cleaned them up and fixed them. So permanent record, very important. So ferromagnetic materials, for the most part, and I'm just giving you a rough overview, but chrome, iron, and nickel are our three materials if we look at the periodic table. And ferromagnetic, this is a term that we use for a material which exhibits both magnetic hysteresis and saturation. I'm not going to dive too deep into those. And also the magnetic permeability is dependent on the magnetizing force present. But ferromagnetic means we can magnetize the material. Aluminum, copper, those we can't. The big one here is iron. Magnetic particle testing, we're only going to do ferromagnetic materials. We previously talked about dye penetrant testing, and there we could use it on all types of materials. Here we can't. We can only use it on ferromagnetic materials. If we can stick a magnet to it, it'll work. If we can't, it's not going to work, this process. Indications, here's another term. Any signal or marking obtained in a test is an indication. Indications we need to interpret. Gets back to being a flaw, so we need to interpret them. We can have false indications. Something shows up on a part or in a scan or a test, and it's like, okay, it's a false positive. It's an indication, but it's not a valid indication. So we can have that going on in non-destructive testing. And then we can have acceptable indications and rejectable indications. If it's a rejectable indication, at that point it is a defect, and we deal with it. So a magnetic leakage field, the magnetic field outside of the part resulting from the presence of a discontinuity or a change in the magnetic permeability or a change in the part's cross section. So you can see here where we've got our little notch cut in the part, and it's causing our magnetic field to circumvent that location. And then when we put our iron powder on there, those particles are going to accumulate in that magnetic leakage field. So once again, transverse slot right there. You can see we've got a notch cut in there. That's where our particles are going to show up. So with a transverse slot or discontinuity in the bar magnet, we're going to have a leakage, and then we're going to have a north and south pole on either side of the discontinuity, and we're going to end up with the magnetic particles there. And that's how we're going to find our discontinuities, because those particles are going to show up and we're going to see them. Like I said, the resulting leakage field will attract mag particles. And this is going to allow us to see really fine cracks um, that we wouldn't be able to see with the naked eye. Now, a reference standard would be something that we use to judge the status or acceptability of another part. So a lot of times we'll have like this stair step. We can use that to measure the radiation that's getting to a piece of film. So we'd shoot an X-ray of this, and then there'd be different levels of darkness or how light on the radiograph, and that would give us an indication of, it would give us a standard that we can work with. So a lot of times we have reference standards for ultrasonic testing. We'll drill holes in a piece of metal or put a crack in there, and then we'll find that crack. We know where that crack is, and then in that particular part, then once we get into the production, and if we find something similar, okay, we know that that crack looks like what a crack looks like because we found it on our reference standard, and we're finding the same thing here. So that's what we do with reference standards. Trade-off. And this gets back to just basic English language. Mutually exclusive events or condition that often require a choice between them. So with some of these non-destructive testing methods, there's going to be a trade-off. What do we want to do? We can trade this for this. We can, this type of non-destructive testing works really, really well, but this is what we're going to have to give up to get that. Or this one doesn't work as well as that one, but maybe it's a little cheaper and easier, but it gets us to where we need to be. So we've got the term trade-off. It's, like I said, exchanging one state or condition for another with subsequent losses or gains. So that's what we're talking about. With the different non-destructive testing methods, there are going to be some trade-offs between the different methods, depending on what your outcome is and what you can live with and what the customer can live with and what the requirements are. Gary A. Pace, P.E., CWI, Katy, Texas, TexasWeldingEngineering.com. You got any questions, comments, thoughts, concerns? This is how you can contact me. Shoot me an email, ask questions. I generally get back to people with an answer.